Molecule bromine pentafluoride. I'm going to do bromine pentachloride. Should be pretty similar, but you'll have to adapt it. Draw the best Lewis structure. Label any atoms with non-zero formal charge. Let's start there. So bromine has 7 electrons. Each chlorine has 7 valence electrons, and there are 5 of them. Add that all up, you get 42 electrons. The bromine is less electronegative. It is also listed first in the formula. Those are both ways that hint that it is the central atom. And now there are 5 things around here. That means that just by attaching the chlorines to it, bromine will have an expanded octet. That's fine. We said that any atom from in the 3p area of the periodic table and below can have an expanded octet. Now, filling these all in, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And now all my chlorines have octets, but I still have 2 more electrons. And that's always the thing with these types of Lewis structures. The question being, is there a pair of electrons on the central atom? If so, that's going to mean that not only does the shape change, but also when we draw dipoles and when we ask, is the overall molecule polar? So it's an important thing to make sure that we get right. Let's see. So that's A. If you do a formal charge analysis, you will see that all of these atoms have 0 formal charge. Now we're going to draw the correct shape. For bromine with 6 electron groups, that's 5 chlorines and 1 pair of electrons. The shape is going to be octahedral. And again, let's just review all this stuff as we go. The hybridization will be sp3d2, and the bond angle will be 90 degrees. Well, hold on. So 90 degrees is octahedral. And because there's a pair of electrons on the central atom, our bond angle answer, the best bond angle answer, is less than 90 degrees. And really it's going to be, you know, what do I mean by less than whenever I say less than? So each pair of electrons generally leads it to be about 2 degrees less. So it would really be about 88 degrees for each of the bond angles. But less than 90 degrees is the answer I'm looking for. We're drawing the correct shape. The correct shape for 6 has 1 straight up and 1 straight down, and then it has what's called an out wedge and a back wedge on the left. It has an out wedge and a back wedge on the right. And then we can go ahead and place into each of these positions one of these things. And since all of the bond angles or all of the positions are equivalent, it doesn't matter where you put the pair of electrons. I sort of messed this up, so I did it in pen, but I'm going to scribble out that one and put my pair of electrons on top. And so I'm just going to put them right there. And then in each of the other positions, I need to have a chlorine. Like so. So that is a good drawing of the shape. Each of these bond angles is less than 90 degrees, a little less than 90 degrees. This bond angle is less than 90 degrees. All of these are. Any questions so far? Oh, it says label each bond angle, so I better do that. Not less than 90 degrees, less than 90 degrees, less than 90 degrees. That was part C. Oh, let me go back to part B. Also draw the dipole for each bond. The dipole, well, bromine is less electronegative than chlorine, so the dipole will be a plus arrow pointing towards each of the chlorines. Like so. All right, let's see. Check, check. Label each bond angle. Ah, right. Check. What is the electron geometry around the bromine atom? I already did that. Check. Are the bonds in the molecule polar? Yes. A polar bond just means that there's two atoms with different electronegativities, which is pretty much whenever there are two different atoms. And is the overall molecule polar? Well, all of these arrows, technically these four arrows that are all these out and back wedges, they technically cancel each other out. But all you need to know is that the bottom arrow doesn't cancel, and whenever there's a pair of electrons on the central atom, the dipoles do not cancel. Whenever there is a pair of electrons on the central atom, the dipoles do not cancel. Colon, polar molecule. Right, all right, we got it all in there. So is the molecule polar? Yes. Step by step, we'll answer each of these questions. I think I've answered them all. And I guess let me label them. C, D is here, E, yes, and F, yes. Any questions about this one? Okay.